This video demonstrates Python data visualization on the Iris dataset. This Python 3 environment comes with many helpful analytics libraries installed. We'll use 3 libraries for this tutorial: Pandas, Matplotlib, and Seaborn. First, we'll import Pandas, a data processing and CSV file I/O library. We'll also import Seaborn, a Python graphing library. Current version of Seaborn generates a bunch of warnings that we'll ignore. Next, we'll load the Iris flower dataset, which is in the input/directory. Let's see what's in the Iris data. Jupyter Notebooks print the result of the last thing you do. Press Shift+Enter to execute this cell. Let's see how many examples we have of each species. The first way we can plot things is using the .plot extension from Pandas data frames. We'll use this to make a scatter plot of the Iris features. We can also use the Seaborn library to make a similar plot. A Seaborn joint plot shows bivariate scatter plots and univariate histogram in the same figure. One piece of information missing in the plots above is what species each plant is. We'll use Seaborn's facet grid to color the scatter plot by species. We can look at an individual feature in Seaborn through a box plot. One way we can extend this plot is adding a layer of individual points on top of it through Seaborn strip plot. We'll use jitter equals true so that all the points don't fall in single vertical lines above the species. Saving the resulting axis as ax each time causes the resulting plot to be shown on top of the previous axis. A violin plot combines the benefits of the previous 2 plots and simplifies them. Denser regions of the data are fatter and sparser thinner in a violin plot. A final Seaborn plot useful for looking at univariate relations is the CDI plot, which creates and visualizes a kernel density estimate of the underlying feature. Another useful Seaborn plot is the pair plot, which shows the bivariate relation between each pair of features. From the pair plot, we'll see that the Irisitosa species is separated from the other 2 across all features combinations. The diagonal elements in a pair plot show the histogram by default. We can update these elements to show other things, such as a KD. Now that we've covered Seaborn, let's go back to some of the ones we can make with Pandas. We can quickly make a box plot with Pandas on each feature split out by species. One cool, more sophisticated technique Pandas has available is called Andrews curves. Andrews curves involve using attributes of samples as coefficients for Fourier series and then plotting these. Another multivariate visualization technique Pandas has is parallel_coordinates. Parallel coordinates plots each feature on a separate column and then draws lines connecting the features for each data sample. I hope you enjoyed this quick introduction to some of the quick, simple data visualizations you can create with Pandas, Seaborn, and Matplotlib in Python. I encourage you to run through these examples yourself, tweaking them and seeing what happens. From there, you can try applying these methods to a new dataset and incorporating them into your own workflow.